Hello and welcome to this module discussing Omron MEMS sensor technology and components. My name is Kerry Horan, Product Manager for Sensors and Modules, and I'll be going over this overview of Omron's various different sensing types within the MEMS sensor category. Omron offers a wide variety of sensor components and sensing technology that can be split up into three different categories. Our optical sensors include our basic photomicrosensors, light convergence sensors, and our brand new time-of-flight sensor. Sensing modules include our environment sensor, our sensor evaluation board, and our human vision component equipped with our facial recognition software called OCal. This presentation will focus on our MEMS sensors. Throughout this presentation, I will take you through details on our thermal IR sensors, pressure sensors, airflow sensors, and our seismic sensor. For the first part of this presentation, we will go over the D6t Thermal IR Sensor, available in several different variations. The D6t sensor uses IR technology to read the surface temperature of both stationary and moving objects. With this ability, the sensor is able to detect human presence even when a person is not moving. Depending on the module that is used in the D6t family, the sensor can measure multiple data points within its field of view. Currently, Omron has available 1, 8, 16, and 1024 pixel count resolutions. The sensor gathers raw data which can be transmitted to the attached MCU via a digital I2C output. Originally, this sensor was designed as a product to be used for general human occupancy in living or workspaces. In the illustration in the top right, we see a living room scene with two children reading in the corner. The sensor collects raw data from each pixel and outputs the information into a grid shown below. As we can see, the higher temperature outputs caused by the warmer temperatures of the people in the room indicate that someone is present. In this slide, we will go over each of the sensors that Omron has available within the D6t series. Each of these sensors offers their own advantages in various different situations, including the number of pixels output in the raw data, field of view viewing angle, and object temperature detection range. Recently, Omron has released newer high-temp versions of two of the existing products, the 4x4 pixel series and the 1x8 pixel series. Omron's latest version of the D6t sensor is the 32x32 pixel version, offering not only high temperature capabilities, detecting objects up to 200 degrees Celsius, but also a much higher resolution picture compared to the other components in this part family. Further down in the table, we have an illustration giving a rough estimate of how the sensor field of view can appear when mounted from above. This helps show how an area may be covered by each one of the sensors available. Keep in mind, sensors with a wider field of view may offer a larger area of room to be seen by the sensor, while those with a narrower field of view may offer advantages over longer distances. At the bottom of the table, we see how a given image may look for each one of these sensors. As you can see, we have a much more detailed view of a person sitting in front of the sensor using the higher resolution 32x32 version, as each pixel is able to read the subtle changes in temperature over the entire scene. However, the low resolution 1x1 sensor's single pixel takes into account the average temperature of the entire scene. For this reason, the combination of the temperature of the person as well as the background temperature gives a single output of a much cooler scene. Applications using the 1x1 sensor can be effective, however, in applications where the sensor is much closer to the object that needs to be measured. Omron's 2SM PB pressure sensor is one of the smallest products on the market capable of accurately detecting barometric pressure changes, even caused by fluctuations in altitude. This tiny sensor uses Omron's MEMS technology to read air pressure down to the hectopascal. As detailed in the illustration on the left-hand side of the page, the sensor can detect changes in air pressure as it rises and falls in altitude, particularly useful in applications where one would be looking to detect movement over floors in a building. The sensor can also detect changes in pressure in open air that may be caused by weather changes or pressure within a closed system. One such application involves using these sensors, two at a time, as a way to measure differential pressure. Two sensors placed on either end of an air filter can measure the airflow difference when the air filter is clean, and the user can note how long before the filter becomes too dirty, causing airflow difference to grow. Using the sensor in this method can provide a smart and affordable way to monitor proper airflow in HVAC applications. Here we have a few more application examples for the pressure sensor. The sensor can be useful in medical environments to monitor patient activity. Because the sensor can detect even small changes in altitude, using the sensor on wearable technology can be an easy way for a caretaker to be alerted if a patient falls over or falls out of bed. On the right-hand side, wearable technology can also utilize this sensor to read changes in altitude for those who exercise. The sensor is able to gauge changes in elevation, accurately reading pressure drops and falls corresponding with the altitude. As the user climbs stairs or hills, the sensor can relay this information back to the device and more reliably track their movement. The 2SMPP gauge pressure sensor series is Omron's other product able to accurately detect air pressure. This sensor measures gauge pressure within a closed system relative to the atmosphere. Currently, Omron is offering these products in an analog version. These sensors are also quite small in size, making it a flexible addition to any new or existing system. The sensor can be used in several different styles of applications. Straight air pressure applications can certainly find use in the air pressure sensor as a means to monitor constant pressure readings within a system. Additionally, the sensor can be used to monitor liquid levels within a closed system. Omron has found use for these sensors in fuel, water, and oil level monitoring applications. Here are a few more applications where the 2SMPP sensor has been useful. In HVAC and airflow monitoring applications, the sensor has been used as a way to monitor air pressure to quickly detect problems due to failed air filters or blockages. The sensor can gauge wear of the system by detecting pressure changes over time, calibrating the sensor to detect deviations from expected pressure levels when the system is working properly. For liquid level monitoring applications, the sensor has been used in home appliances, such as washers, to monitor proper liquid levels within the machine. As liquid level falls, as will the pressure, making this a simple way to gather important operating information. Omron offers a wide variety of unique SKUs within the D6f Airflow Sensor family. The large number of products offered within the D6f family cover a wide range of airflow volume, air velocity, product functionality, and body design. All of these different products can essentially be broken down into two main types: flow rate measurement and flow velocity measurement. Flow rate measurement sensors connect directly into an airflow system and measure the total amount of flow as it passes through the sensor. These sensors are available in analog or a digital I2C output. As the air flows through the sensor, the output gives the total flow rate as it passes through, in liters per minute. On the other side, we have the flow velocity sensors. This product type is installed in open air and can measure the partial or total airflow as it passes over the sensor. These sensors are only available in analog and measure changes in air velocity, outputting raw data in meters per second. On this slide, we will go over two applications that the D6f sensor can be used, one for each of the different product types. Flow rate sensors can read airflow up to 70 liters per minute, but on the other end, we have sensors capable of detecting even the smallest of airflows. These particular products can be useful for controlled environments, including lab and medical applications, or ventilators for clean rooms. The sensors can detect accurate airflow in these contained environments and ensure that the readings are up to safe standards for these applications. Users can rely on these sensors, which are capable of detecting even the smallest airflow, even some caused by the flap of a butterfly wing. On the right-hand side, we have information about flow velocity sensors, which are equipped for open air applications, including HVAC or air handling. These sensors can be mounted in the open space of ventilation ducts and measure changes in flow velocity that are caused by old filters or blockage. Using multiple sensors in a single system allows the user to quickly diagnose airflow issues and origins, and can even be used to accurately monitor exactly when an air filter is worn out. Recently, Omron has found success in using various D6f sensors for air and gas detectors and analyzers. Different devices which measure flammable gas or toxic gas or air pollution levels can find use with these sensors as air passes through them to measure accurate airflow. For different applications, we have different parts recommended. For example, in the half to 1 liter per minute flow rate, the D6f P0010A would be recommended. However, for larger size analyzers, flow rates can be up to 10 liters per minute, though Omron has several parts that are capable of these flow rates, even greater and less. In some applications, differential pressure sensors are required, which is also incorporated in the D6f PH family. In certain air and gas detection applications, customers may find use in the D6f Flow Sensor for much higher accuracy and resolution, and for a much lower pressure loss. However, in other applications, the customer may find it more useful to use the differential pressure sensor, the D6f-PH series. These sensors are a much lower cost. However, the customer may require a bypass connection in order to read proper pressure levels. Finally, we have the D7s sensor, capable of measuring seismic activity caused by earthquakes. The Omron D7s sensor was designed to detect the occurrence of any nearby earthquake. The sensor detects vibrations and outputs an earthquake scale and an SI value. The sensor software can actually link to smarter devices to output an emergency signal in case the SI value becomes too high. This sensor can also be linked to smart systems such as emergency shutdowns, so that any machinery that's working with fuel or high voltage can be shut down whenever there is a high SI value detected. The compact design of the sensor allows for flexibility in installation. On this slide, we go over how the user can utilize the sensor to its full potential. The sensor detects the occurrence of an earthquake or other significant vibrations. The raw data collected is output to an MCU via a digital I2C output and calculated to produce an SI value. If the SI value reaches a certain point, emergency actions can be triggered. Shut-off systems can use this sensor as a means to prevent further damage that can be caused by significant seismic events. In severe earthquakes, power and fuel lines can be cut, causing further damage. However, the sensor can be linked to shutoff systems, preventing this from taking place, keeping more people safe. For larger smart city applications, sensors around the area can be used for recovery support. Data can be collected and output, indicating where damage may be more severe, and then can concentrate recovery work on areas with more damage. Here at Omron, we are committed to improving lives and contributing to a better society. We believe in the development of sensors in order to provide new technology and support ongoing production of new and innovative applications. Thank you very much for your time in participating in this module, going over the Omron MEMS sensors and sensing technology. Again, my name is Carrie Horan, Product Manager for Sensors and Modules. To learn more about these components and other Omron product offerings, including switches, connectors, and power relays, please visit our website at components.omron.com.